Hi guys, welcome to the channel. So in the previous video of molecular structures, I signed off with this particular molecule, and I told you guys to just follow the 4 steps through to find out the unsaturation index for this particular molecule. So we'll discuss this one first. After that we will go for rule of 13, right? So I would advise you to go through each of these 4 steps one by one and follow through for that molecule. So for the first step, what we are going to do is using the general formula for saturated acyclic hydrocarbons. The general formula was CnH2n plus 2. So here n is equals to 7. So for n is equals to 7, if we use this general formula, then what we are about to get is C7H2 into 7 plus 2. So when we are going to solve this one, we will get C7H16, right? Now this was the first step, right, out of those 4. Now please read the second step and then we will proceed for the second step. So the second step was the correction, right? So for 2 oxygen atoms we have to apply the correction. So for 2 oxygen atoms we need not do any changes in number of hydrogens, right? So the formula will be C7H16 as such, along with 2 oxygen, right? Now in the third step it was asked to compare these two formulas and find out the difference in number of hydrogens. So if we compare these two formulas, there is difference in number of 2 hydrogens, right? Here hydrogen is 16, here hydrogen is 14. Now this is the third step. After this, the fourth step is to find out the index of hydrogen deficiency or the unsaturation index. That was difference in number of hydrogens, that is 2 divided by 2 equals 1. So the unsaturation index is 1. So now we have this information. Now using this information we can predict that it can have one double bond in the structure, right? Now if we further go for IR spectrum, then we can further confirm the presence of carbonyl bond, C double bond O, using IR spectrum, right? So at that point, number of possible isomers that might include in this unknown compound can be narrowed down as well. That is the main part of IR. But for now we can determine the unsaturation index, and after going for IR spectroscopy as well, we can predict the molecular structure like this. If carbonyl bond is present like this, right? So this could be the possible structure if we go for overall spectral analysis of the compound. So this is isopentyl acetate. Right, so this is about this particular example for this particular molecule. Now we will move on to the rule of 13. So now we will discuss about the rule of 13. So this rule will help us to generate the possible molecular formula for the given molecular mass. So the first step will be the generation of base formula. So that base formula will contain only carbon and hydrogen. For that, what we have to do is, whatever molecular mass we have, just divide that by 13. That is why it is called as, named as rule of 13. So divide your molecular mass with 13, you will get some value n here, and after division you will get some remainder here, right? After the division you will get some value n here and r here. Now why we take this 13? Reason being, if you add the masses of carbon and hydrogen, then that comes equals to 13. So we divide the molecular mass by 13. Now after we are done with the division part, we will generate the base formula. So the base formula will be CnH n plus R. N is this, R is this. So this will be the base formula. After this, we can also determine the unsaturation index, that is U. U will be equal to N minus R plus 2 whole divided by 2. So this will be the unsaturation index. So these are the two important formulas which we are going to use, and before that we have to divide the molecular mass by 13. We will get the values of N and R. Substituting these two values in these two formulas, we will get the base formula and the unsaturation index. So we'll understand this with the help of an example. So for example, suppose we have an unknown compound and the molecular mass of that compound is given as 94. Now how we are going to proceed? First we have to do is, molecular mass is 94, divide this by 13. So from here we have got the N value equals to 7 and R value equals to 3. These two values we have got. Now using these two formulas we will get the base formula and the unsaturation index. So for base formula, C7H7 plus 3, this will be C7H10. This is the base formula. Now for unsaturation index, it will be 7 minus 3 plus 2 divided by 2, that will be 3. So if U is equals to 3, right, so it should contain some combination of 3 rings or multiple bonds. So one possible structure could be, suppose there is one ring and there are 2 double bonds and we have 7 carbons, so 6 carbons are used up in this ring. This is the 7th carbon and we will try to balance the valencies. So this could be one of the possible structures. So no doubt there are a number of more possibilities, like if heteroatoms are present. So combination of all of these information along with other spectral information will help us to identify the exact structure. Right now we only know the molecular mass. So from that we can determine the base formula, unsaturation index, and we can predict, like, this could be one of the possible structures. Getting more information, we will go down further to the exact structure of this molecule. So I hope till now everything is clear to you guys. In the next video I want to introduce some more topics in this series only. So I want to start with electromagnetic radiations, a brief theory about the electromagnetic radiations. Then we will discuss about the emission and absorption spectra, then some of the terms like wavelength, wave number, frequency, energy, like that. And then we will discuss in detail about the overall electromagnetic spectra, that is how it is composed of, like the cosmic rays, gamma rays, x-rays, UV visible, IR, micro, radio waves, like that. We will discuss the overall spectra as well. So these small topics I want to include in this series only. So I hope till now everything is clear to you guys. and the video was helpful for you. So far that's it for this video. Thank you so much for watching.